Hello everyone, good afternoon. So today I'll be presenting my knowledge session on building and deploying ML model on Azure ML Studio, as you might have heard of. So the topic is pretty self-explanatory. So let me move on. So before starting this session, let's remind ourselves of the knowledge etiquettes that we have. First is punctuality. Like we should be joining the session 5 minutes prior so that we can start and end on time. And then the second one is feedback. Make sure that you're submitting a constructive feedback for all the sessions, as it is very helpful for me and also the other presenters. The third is silent mode. You should always keep your mobile phones on silent. If you have to move out of the set, if you have to attend a really emergent call, then you can feel free to move out of the session. And the lastly is avoid disturbance. Please avoid unwanted chit chat during the session, as we will have a separate Q&A panel at the end of the session. Now, moving on to the agenda for today. So at first we are going to cover, we are going to start with the introduction, and then in the introduction we'll be looking at a simple concept like what is machine learning and what a simple machine learning lifecycle looks like. And then we are going to create it, and we are going to also understand it visually. Then the second way we are going, then in the second one we are going to look at the overview of Azureml, what is Azureml, and then some of the features that are provided by the Azure ML, and then also the Azure ML Studio Designer that we will be mainly utilizing. We will be looking at some of its feature and why are we using it. Then finally, we will be covering some of the benefits of using Azure ML Studio. Then in the end, the main crux of this session is going to be the understanding the workflow and the full pipeline, the full ML pipeline creation. So we will be starting with the data ingestion and the preparation pipeline. Then we will be looking at model selection and the model training pipeline. Then after that, we'll be looking at model evaluations. Then finally, after our model is evaluated, we will be looking at scoring the model, and then we will be looking at the deployment part. And then finally, we'll be looking at basically monitoring and optimization along with some of the best practices. And then after the theory part is done, we'll be moving on to our demo and then finally Q&A. So let me move on to our introduction. So at first, one of the main questions that arises is what is machine learning? So according to Arthur Samuel, like a famous mathematician, so he said that the machine learning algorithms enable the computer to learn from data and improve upon themselves without being explicitly programmed. So we are going to provide it some data with some output that is going to be correct. It's going to learn from it, and then we are going to remove the input and we are going to remove the output from it. And then eventually, when we are going to provide it with some random data that we have, like random similar data, it should predict whatever the model has learned during the training process. So one of the basic premises of the machine learning is to build algorithms that can receive input data and use the analysis to predict an output while updating its output as the new data becomes available. So basically in simple terms, exactly what I explained you, right? So we are going to be providing it some input, and we are going to be expecting some output. So now looking at the machine learning lifecycle. So this is what a typical machine learning lifecycle or a pipeline looks like. So at first we are going to be always starting with the data set, and then we will be moving, because the raw data set that we have is will most of the time will be containing a lot of noise and will require data cleaning. So we have to do the data processing, and so inside the data processing we have certain steps like data cleaning and the feature engineering. So we need to do that. We will be cleaning our data, and then finally we will be selecting our we will be doing feature engineering. So feature engineering is nothing but we are selecting whatever the columns we want the model to train on, what are the columns that we want to exclude it, that we don't want to train it on. They are like basically redundant. And then finally, after we have prepared our data that is fully clean and stuff, then we will be finally splitting our data into a training data and our test data. So this new data here is basically our testing data or our validation data, or you can call it. Then we will keep the validation data on hold. Then using the training data, we are going to be inputting this training data into a learning algorithm. The learning algorithm will be our machine learning algorithm, using which our machine learning model is going to get trained. And then finally, after the model is trained, we will be getting a model. Then the model is going to get validated using the test data that we have separated earlier, and we will generate some scoring. And then based on that scoring, we can check whether the model is accurate or not, whether the model is able to perform. And then we can tweak basically we can tweak the data cleaning process, we can tweak the feature engineering process, and things like that. to make the model more accurate if it is not. So this is what a very simple basic machine learning lifecycle looks like. Now moving on to an overview of Azure ML. So basically, let's start with a simple introduction of Azure ML. So Azure ML, as you know, as you all know, it is basically provided by Microsoft. So what it offers us tools for building and training and deploying ML models. Very simply put, right? And it also helps us to integrate with Microsoft Azure services for streamlining workflow. So there are multiple Azure services such as like Key Vault and containers, and then blob storage, container registries, and it also like enables us to like streamlinedly integrate with them easily. It also supports AutoML for easy model creation. Suppose you don't want to, so suppose you don't want you are not particularly sure which model to go on. You can put in the you can put in the data in the AutoML pipeline, and then it will automatically train multiple models, and then it will automatically select which models are the best, and basically it will give you results, and then you can choose which model you want to deploy or you want to carry forward. It also provides the MLOps capabilities for managing the whole ML lifecycle, as I told you earlier. And then it also offers a scalable infrastructure for ML experimentation and deployment, as because there might be data sets that might be very large, or the models that are built very large. So, and you might also need to scale your environment so that you want to handle traffic, handle model, basically handle model training, model building processes. So these are like auto scaled, and you can also enable them like manually. And it also enables collaboration and version control with using the built-in features. And then finally we have like it mainly simplifies the AI development process, and using pre-built models and the pipelines, and making and presenting it in a visual format. And finally it empowers our business to harness to harness AI in like various use cases efficiently. Now moving on to some of the Azure ML features that we have is it has like a lot of pre-trained models that are available already, so that you can just access the repository and just use it directly on whatever data that you have, or you want to do the predictions on. Then finally, then one of the other things is that it has the very important feature is that security and compliance. It has like built-in security features and compliance certification, and basically identity management tools for ensuring a robust protection. So they are available like online. As soon as you create an Azure ML Studio instance, they are going to be automatically created. And finally, it also supports features like such as TensorFlow and PyTorch. And there are other, so one of the other things that I told you about, it also seamlessly integrates with other Azure cloud platform services, so that it basically we are able to deploy a model, we are able to create inference clusters, we are able to do multiple things like super easily. And also it facilitates quick prototyping and the use of transfer learning to speed up to speed up the development. Then finally, not but the least, so there might be like, suppose if you don't want to use the pre-trained models, if you don't want to use the pre-trained data that is available, right? So there are like custom environments, custom pipeline creation that you can do, and then you can import your own data from the blob storage, and then you can create your own pipeline, create your own model, and then deploy it. So it also enhances, it also has those features, and then you will be able to like make basically a custom pipeline according to your needs. Then finally, it enables effective resource management with enterprise level support and scalability. So yeah. Now moving on to one of the major things that we are going to use is the Azure ML Studio. And so basically Azure ML Studio, it basically provides us an intuitive drag and drop interface for creating ML pipelines without coding. So it is basically a low code to no code solution that has been provided by Azure ML. It also supports like the end-to-end ML lifecycle process from data ingestion to deployment and monitoring. And it also supports like AutoML, as I told you earlier. Like, say if you don't want to particularly, if you don't think that this model, this training algorithm is going to be better, then if you can train basically multiple algorithms, then you can select whichever performs the best, right? And then also it also supports hyperparameter tuning and other things. Now, so one of the other things that I told you about earlier, that it also supports custom environments. So the custom environments and the custom pipeline that you have to build are supported using the integrated notebooks, and the integrated notebooks are nothing but the Jupyter notebooks that are basically embedded inside the Azure ML Studio that you can utilize, and then you can import your data from the blob storage, and then you can perform like normal coding, and then do train the model, and then you can put it. Then you can register the model through the Jupyter itself, and then you will be able to deploy it easily. So from the Jupyter notebooks, that custom pipeline creation is also possible. And third is like it has like data preparation tools such as data cleaning, data transformation, and feature engineering in a very neatly packaged way. So it is basically a simple drag and drop feature. You don't have to write any code. You just have to attach. You just have to drag it into the canvas and just attach it, and then you will be able to select whatever columns you want, whatever columns you want to remove, whatever transformation that you want to uh, do. Then the other thing is like model explainability. It has built-in tools. Suppose the model is trained, and then you want to see like what are the scoring models. So you will be able to using the drag and drop feature, you will be able to see what is the output for the model, what is the performance of the model, what is the accuracy of the model. You will be able to see it simply without doing any code or any coding at all. Then it is like auto scalable, as I told, as it is pretty basically self-explanatory. So then there is model deployment, and one of the other things about model deployment is that it is very simple. They have made it super simple, that it is literally a two click of a button, and then you will be able to simply deploy your model either for real-time prediction or for batch predictions. Moving on, so as soon as you have created pipeline, the whole pipeline. So if you want to track it, if you want to run the whole pipeline, you can. So there is going to be a job section that I will show you in the demo, from where when the pipeline is running, you can keep track of all the experiments or all the prior experiment that you have run. So it will keep track of everything, basically your model, your data sets, your results, and you can basically view it anytime as it saves. As it also has like a basically auto save feature. Then it also enables like team collaboration with shared workspaces and version controls. So there is also like a share feature that you can share your whole pipeline with other people, and then if you give them the permission. And then also, as I told you earlier, it has like enterprise grade security with basically the role based access, right? So that is basically that security and the compliance is going to be enabled as soon as you create basically Azure ML workspace. So this is basically whatever Azure ML Studio looks like, and it is so this is basically a drag and drop canvas feature. So this is called the designer interface. So here, as you can see, we are basically dragging the ML data. We will be able to simply drag the split data, and then we will be able to uh, connect our data set to the split data, and then we will be able to provide some algorithms, whatever we want. So there are like multiple algorithms that are available in the component section, and then we will be able to choose whichever algorithms we want, and then we can simply attach those algorithms to the train model section. And then from the train model section, we will be able to, like, after the model is trained, the pipeline is run, we can simply move on to the scoring model and the evaluation model. So this is what like a very simple basically pipeline looks like, and somehow and it is very similar to what we are going to create. So as you can see here, we are not doing any coding at all. We are just simply dragging and dropping these components, and then we are just selecting whatever columns that we are going to choose, whatever model we want to choose, and then we will be basically able to build this whole ML pipeline. I will show you this more in detail in the demo section. So yeah. So basically, as I told you earlier, that Azure ML Studio Designer is basically a low-code to no-code solution that we are able to like easily visually build, train, and deploy machine learning models using a canvas, right? So what are the benefits of Azure using Azure ML Studio Designer, and why should we use it, right? So it provides with like no code to low code solution. It allows building a training model without writing a code, so it is very easy. It is very easy and also very simpler for beginners to learn also. And it has a simple drag and drop interface. We can just simply simply drag the components, and then we can just simply use the pre-built modules that are given to us by Azure. So it is a completely visual workflow that looks neat, and then it is also very easy to manage and easy to basically deploy and easy to do other things on. And it is also like it is also very simple for like for basically any other person that is learning the model, it is very easy to understand also. Then we also have like multiple pre-built modules that are available, such as data preparation, model training, evaluation, deployment modules. So you don't really have to worry about that you have to write some code for model training, you have to write some code for data cleaning pipeline, or you have to write some code for feature engineering or for evaluation. You can just simply use the pre-built modules and then just simply drag and drop it. Then regarding the integration part, it seamlessly integrates with other Azure ML services. Suppose you want to use a data that you have custom that you want to train a custom on basically a custom data, right? So you can basically easily integrate with the Azure blob storage, and then you can create compute clusters for it, and then for basically the model training purposes and stuff and the deployment. So all these processes are like seamlessly integrated. It also supports it also supports like custom code, as I told you earlier, using the Jupyter notebooks. Then it has like real-time experimentation. You can quickly test different models and it will show you the results on the canvas itself with just a few clicks. And the deployment is also like just basically a two-click process, and then you will be able to simply basically deploy your endpoint, and then anybody can use it. So this is what basically Azure ML designer interface looks like. So as you can see here, so you can see like on inside the authoring section, you have like notebooks. So these are nothing but the Jupyter notebooks that you want to create. So then there is automated ML section if you want to create an automated ML pipeline. Then there is the designer section that we are going to use. We are going to be dragging and dropping, and we are going to be creating a machine learning pipeline from scratch. Then there are the assets section where you will be looking at the data, job, components, pipeline, whatever pipeline that you have run, whatever endpoints that you have deployed, all are going to be listed here. And then you can finally manage the compute and the monitoring and the data labeling part in the last section, right? So this is a simple, we will take more look into it like in the demo section. Is anybody saying something? Okay, I guess not. So let's finally move on to our main crux of the session is going to be understanding the workflow. So at first we are going to be basically dragging and dropping our we are our data set, and then we are going to be then we are basically going to be doing our feature engineering and our data cleaning steps, right? So at first we have, so there are multiple data sources that are already supported, and then you can also integrate your own custom data that you want to use using the Azure blob storage, as I told you earlier. Then for the data transformation pipeline, there are multiple tools for data cleaning, transforming, and feature engineering that are available from the component section. You can just simply drag and drop from the designer interface. Then there are multiple, then for the feature engineering purpose, suppose your data is not scaled. If you want to normalize your data, and then you want to select certain features, you want to replace the missing values, you want to do basically feature engineering and feature engineering and data processing, there are multiple pre-built modules that are also available, and then you can just simply drag and drop it from the from basically the component section. Now we will be also doing some of the normalization, because normalization is usually necessary, because it basically what it does is that it basically standardizes our data to a common scale without basically distorting the differences in the range of values and improving model performance. So suppose like just take an example. So suppose the prices can be in the range of like 10,000 lakh. Like just take the example for like automotive price data, right? So the prices for automobiles can be in the range of lakhs, and like minimum in the thousands range. But suppose if you want to compare it to the mileage range, the mileage is most of the time is going to be in the 2-digit place. So now the scales are completely different. So if we are not scaling these two features, what will happen is that the model might get confused, and the model, due to which, if the model gets confused in the scales, and then it ultimately it will result in like bad model performance. And also at the same time it can also basically the accuracy drops, and then so that we need to basically scale them properly, so that the model doesn't get skewed and basically prioritizes some other features more, and then it doesn't become like biased towards a certain feature. And then finally, after we are done with our data ingestion and the preparation pipeline, we will be splitting our data into training and validation sets. That will I'll show you in the next slide. Now the other, now after you have done the data preparation, now we are going to splitting the data. We are going to train our model, and we are going to be selecting an algorithm. So for basically selecting an algorithm, the Azure ML Studio, it provides us with basically a wide range of built-in algorithms for classification, regression, clustering, and many more, right? So that you will be, so as you can see here that I have used as you can see here that I have used here the linear regression algorithm. So you can just simply drag and drop this into the canvas, and then you can just connect it to the to basically the training model canvas step. Then for the automated ML, you can also use the automated ML feature, but we are not covering that today. So let's skip it for now. And then we have our basically the training and our training and configuration. So it's a simple setup that you are going to be, so whatever data that you have prepped, that you have normalized and that you have completely prepped, you are going to be inputting it into the split data pipeline. And then splitting data, you will be splitting your data into a training and a validation set, right? So it could be basically 80-20 ratio or 70-30 ratio, like so these two ratios are preferred. And then you will be putting the training data into the train model pipeline, and then the resulting data will be going into our evaluation canvas step, right? And also Azure, like, it automatically scales depending upon the size of the data that you have. And suppose if you have a very large data set, and you have not if you have a compute instance that only has 2 cores, it will automatically scale to suit your needs. Now moving on to the model evaluation part, as you can see here that for model evaluation part, similarly that you will have pre-built modules that are available called score model and evaluate model. As you can see that from the train model, I have connected the train model into the score model, and the validation data set that I have split it, I have basically connected it into the score model section. So using that validation set, I am going to be evaluating our model, and basically our scoring our model, and then finally we are going to be evaluating. So these two are like very simple features, and they are basically available on like just a whim. You can just simply drag and drop it from the component section. Also, if you want to like visualize it, if you want to look at accuracy, precision, recall, and other metrics, you can also simply drag and drop the cross validation component, and then you will be able to see the performance such as accuracy, precision, recall, and etc., right? So these are all the features that are available, and then finally you will be able to like fully basically evaluate your model and see the results, whether the model is performing well or not. And if it is not, then you will have to tweak certain things in the then you will have to basically tweak certain things in the preparation pipeline, and then maybe use different models, different parameters, and then you have to basically test and see through it, like run through it. Now moving on to, so we have completely trained our model. Suppose you have a trained model ready, you are happy with the model accuracy. Now if you want to deploy the model, so deploying the model is also very simple. So there are multiple ways that you can deploy. So either once you have trained the model, you can directly register the model through the training canvas step and then deploy it from there. But we will not be doing that. We will be doing it more visually, so that it is a lot more simpler to understand, and also better to look, and it is also a lot more easier. So one of the other things that once we have created our whole ML pipeline in basically our Azure ML Studio, we have to create basically an inference cluster, so that it can take input and then it can give basically some output, right? So setting up inference cluster might seem like a daunting task, but it is not. It is they have made it so easy that you can just simply click on it, and then as soon as you click on it, uh, like within like 3 or 4 seconds, is going to create a whole pipeline along with the inputs inside the canvas itself, that is going to be using your model that you have created. And basically the inference cluster creation is going to be like basically managed automatically. Then after the inference cluster the inference cluster creation and the inference pipeline has been created, what you will have to do is you have to first run this whole pipeline. So to basically to check whether this whole pipeline works or not. So like, yeah, of course, so you have to run it. And then after the inference pipeline has succeeded, and it will show you that it has succeeded, right, in your pipeline section, then you will be able to basically simply deploy it. So I'll show you in basically the demo section. As soon as your inference pipeline is succeeded in the in basically the designer, you will be able to see a deploy basically a deploy button get enabled. And from using that deploy button, you will be able to use the inference cluster that you have just created, and either deploy it through like AKS cluster or using the Azure container instances. So depending upon how heavy your model, or how heavy, or if you want to like if you want to build like a whole production level system, then you can use the AKS cluster. If you don't want to, if you're just testing it out, if you're doing just some minor task, you just want to like feel through the environment, like just like look and feel and see, then you can simply use the Azure container instances. Then then so basically what will happen is that once you have clicked on the deploy button, it is going to create the deployment pipeline, and it is going to completely run it. And it usually takes about 15 to 20 minutes to create and run the whole pipeline. And then the endpoint, basically a RESTful endpoint, is automatically generated in the endpoint section of the ML Studio, so that you can simply move on to the endpoint section, and then you can click on the REST endpoint, and then you can interact with it using Postman. Or if you want to test it through the Azure itself, you can also do that. Then the one of the other things is that the deployment configuration and the version management is also available. And because the deployment configuration, you will be able to particularly see which when you are deploying, what resources that you are allocating. If you want to scale your deployment, as soon as the model is deployed, you will be able to select and choose all these things and modify these things on your whim, right? Then finally, it also supports like two types of prediction, is just like real time or batch predictions. If you want to have real time predictions with just like one input or two input, then you can do that. Or also if you want to have like bulk prediction, if you want to provide it with a certain amount of data set, and then you want all the results, it also provides that also. So yeah, the batch prediction is going to be a little bit slower. So if you're like time constrained, then yeah, it won't work. It won't give you results like super fast. But yeah, so these two type of predictions are supported. So after the deployment is done, now the main part is about the monitoring and optimizing our whole ML pipeline that we have already run. So there are multiple matrices that I already told you about, that you can utilize the drag and drop features like cross validation, evaluate model, a score model. So from there you will be able to see what is the accuracy, precision, and basically all the other metrics that will be able to that you will be able to check and see whether your model is performing well or not. Then for the resource utilization part, you can also monitor the CPU, GPU, and the memory that is being consumed, and you can also optimize it. Suppose if you have like suppose if you have like a really big machine, and you see that the resources are not getting utilized, then you can simply like downgrade it, you can simply upgrade it. So it also supports those type of features. It also supports like basically you will be able to also identify the shifts in input data distribution to retrain our models accordingly. Suppose if you're providing multiple input data, and then suppose when you're providing multiple input data, and then the data, if you think that the model is not performing well on the input data, you will be able to like basically simply retrain your whole model, whole pipeline, simply just with a click. And then also you don't even have to change the endpoint, as one of the other features of the Azure ML Studio is that it automatically replaces it automatically has the feature to replace the old endpoint that you were using earlier. So yeah. Then there are other features such as model drift detection that it has, and the auto scaling feature that are like self-explanatory that I have covered earlier. Then there is experiment tracking, that you will be able to see which experiment that you are using, like simply through the pipeline section. And then finally, after the deployment is done, you will be able to monitor the cost that is associated with your deployment and with your instances, and then you will be able to manage it effectively. Now, in the end, there are going to be some best practices and recommendations that are like in general recommended. So some of the consideration is that that we must implement like monitoring and logging mechanism so that we are able to log and monitor like whenever if something happens to our ML pipeline or if it fails or if there is some error we are able to like resolve it quickly. And so Azure also provides us with like the monitoring tools that are easily integrated, so you will be able to utilize the Azure tools itself for monitoring the security and compliance. As the Azure has feature of keywords, so all those keywords will be already created, so you don't really have to worry about that. But if you want to, if you want to share it, if you want to like share your pipeline with some other people, if you want to deploy it in certain way, if you want to manage it somehow, then there is also a feature of basically sharing your pipeline. If you want to version control it, if you want to suppose if you have a custom pipeline, if you want to import it into GitHub, so these type of things will be supported by Azure, and will be managed by Azure itself. Then there is finally there is one of the things is that the one of the most important things is the documentation and the knowledge sharing part, that you must like whatever pipeline that you're creating, you must have like a proper documentation, so and also so that the documentation will be helpful to you and also for the other people. Then finally you must establish like a feedback loop or for model iteration, or you might just like if you are satisfied with the model, but you need to keep like checking on different data types, so that whether you can check whether your model is performing up to date or like well with the current data that is being inputted through our endpoints. And then finally, the performance optimization. If you see that the model is not performing well, or maybe this model is performing well, but you have found an alternative model that performs way better, right? So that you can simply you can simply deploy that model and replace it with your old endpoint. So these are the things that you can you need to keep in mind and consider before building basically an ML pipeline. Now let's move on to the demo section. And so this is what our basically a Microsoft Azure platform looks like. So what we are going to be utilizing is Azure machine learning. So you can search it from here, search bar, and then once you go inside the Azure machine learning, then from here you need to create a workspace. So I have already created a workspace, but simply once you do here, if you can create a simple workspace, you can assign it a resource group that you have, and then you can simply give it a unique name, and then it will create the associated storage account keywords and the application insights automatically. And then you can just simply click review and create. I'm not going to create it again because I've already created it. So I'm just going to show you that. So as soon as you open this workspace, you will basically give me just 1 second. I think there's somebody at my door. Yeah. Hello. Yeah. Kind of sorry for the disturbance. There was somebody at my door. All right. So uh, now, once you have created the ML workspace, you will be able to simply launch the studio. As you can see, this launch studio button, it is going to create your keyword, your Azure Blob Storage. It is going to automatically create those. So once you click the launch studio button, it is going to launch the Azure ML Studio. So Azure ML Studio looks something like this, and it is going to have your ML workspace name. And as you can see here, you will have like notebook section, automated ML section, and other multiple sections such as data, jobs, pipelines that you can monitor. And finally, you have like sections such as monitoring, compute, and data labeling, right? So mainly we are going to be utilizing the designer so that we will be able to custom drag and drop and create our ML pipeline in a visual design format. So this is what our designer looks like. So I have already created some pipelines because usually the pipeline creation and the running the whole pipeline takes a bit of time, like almost like 10 to 15 minutes close to. So that's why I've already created some pipeline. So let's look at this pipeline that we have created. So here, as you can see, that I have basically inputted the automobile price data. You might be saying like, from where did we obtain it? So if you go into the component section of the Azure ML Studio of the designer, you will be able to simply search automobile, and then you can simply see that there is like there is like pre-built raw data that is available. So there are like multiple data sets that are available that Azure provides us, so that you can simply use and test things on it. So all these other features that here, as you can see here, they are all available in the component section. So you just have to search for it, and then you can simply just drag and drop it into the canvas. So it makes it very simple and like streamlined. So once you have dragged the data set, then you will be able to simply select the columns that you have. So if you just double click it, you will be able to go into the edit column section, and then whatever columns that you want. So here, as you can see, I have selected based on the column names. I have selected multiple columns that I want to include. So as you can see here, price, highway mileage, city page, horsepower, peak RPM, compression ratio, bore stroke. So these type of columns, and then you can save this config. So suppose if you want to suppose the as the raw data has like has like a lot of noise, and it has like it might be having some missing values, you will be able to simply clean your missing data also. So what I've done is that there were a lot of values that were missing inside the bore stroke and the horsepower section. So I have basically selected those columns, and I have inside the cleaning mode, I have selected that I want to exclude the entire row. So it depends. You can replace it with the mean. You can replace it with the mode. So or maybe you can if somehow if somehow you want to replace or remove the entire column, you can also do that. So all of these features are also available in this section. Then finally we are going, after cleaning our data, we are going to be normalizing. So all these pipeline are also available in the all these steps are available in the component section. So in the normalization section, we are going to be utilizing the min max scaler, and then we are going to be scaling our columns and our values. So inside here, if you go to the edit column section, you will be able to provide whatever columns that you have. So you can just simply type it, and then you will be able to select whatever column names that you want to basically scale, and then you can simply save it. So as you can see here, it makes it like very simple and easy to understand, right? So after you have done your normalization and you are completely okay with your data, then you can finally drag and drop the split data feature, and then inside here you can split the data. So I have currently splitted the data in like 70-30 ratio. So the 70% is going to be used in the training part, and I've used a random seed to randomly split the data. And I have basically enabled the stratified. I have basically disabled the stratified splitting. So these are some of the things that are available in the splitting. Splitting is very simple to understand, right? Then finally, so once you have splitted the data, so keep in mind, you don't need to run all these pipelines. You can just simply connect all these steps, and then finally you can just run it once you have connected all these steps, right? But if you want to run certain instances, suppose you only want to run it till the normalize, if you want to disconnect this, and then you can simply run this pipeline also. So it basically completely suits your needs. So suppose if you're not happy with the normalization, and if you want to retrain it, so if you want not retrain it, if you want to basically rerun just these four components, you can remove them, and then you can run these four components separately. Then finally, we have basically from the canvas components, we have dragged the linear regression model here. So you will be able to, if you search like regression, you'll be able to see that we have like multiple models that are available, such as decision forest, neural network, Poseidon regression. So these are all the models that are available that you can simply drag and drop. If you want to drag and drop classification, you will be able to also drag and drop those components also here. Then we are going to be connecting our trained data into our training model section, and we are going to also be connecting whatever algorithms that we are going to be using to our to basically our train model section. So we are going to be inputting train model and our whatever algorithm. So based on this algorithm and the train data that we are providing, our model is going to get trained. Then after the model is trained, we want to score our model, right? And see how it is performing on the validation set that we have split. So basically, the split data, that is our test set, we are going to be inputting that data set into our scoring section, and then we are going to be tallying it and verifying it with the trained model that we have. So as you can see here, I have connected my trained model directly into the score model section, and I've connected the validation, the basically the 30 split that I had for training. to our score model section. Then finally, if you open it, you will be able to see like what are basically the parameters. So there is like no such parameters that are required. So you will be able to simply like see it. So once this pipeline runs, I will be able to show you like what are the results of it. And then there is like the evaluate model pipeline. So after you have dragged and drop and established like this simple pipeline, you can just simply do configure and submit. And then from here, you will be able to select basically whatever auto prices, select basically whatever the experiment name that you have. If I already have created an auto price experiment, so I'm going to use that maybe. And if you have not created, you can click on create new, and then you will be able to create a new here, new pipeline here. And then finally you are going to be choosing, let me just move on and see, let's go to the next section. So you can skip this, and then here basically you will have to select whatever cluster that you are creating. I don't think I have told you about creating the cluster, so I'll show you this now. So once you go into the compute section of this pipeline, as you can see here that I already have a cluster running. So this whole pipeline is going to be utilizing a machine, right? Basically a compute instance, right? So whatever the compute instance that we are going to utilize, so we need a compute instance to be able to run this whole design that we have just created. So simply you can create a new instance, and then you can, whatever you want to utilize, you can give it whatever name that you want. And then suppose depending upon your data set or on the scale of the model that you want to create, you can choose multiple machines, and then you can utilize CPU, GPU, and then you can just simply review and create it. I'm not going to create this again because I have already created it and it is already running. So yeah. So as soon as you have you have selected and you have configured and submit your pipeline, you will be able to run this. The whole pipeline is going to be automatically running. And then inside the job sections, you will be able to monitor. So as you can see here that I have like inside the jobs and also inside the pipeline section, I will be able to, you will be able to see whatever pipelines that are currently running. So if I go to this pipeline that I have run, you will be able to see that all these steps that have been like completely like executed. And then you will be able to see like finally in the score model section, as you can see here, like, let me show you preview data, evaluation results. Yeah. So as you can see here, like whatever model evaluations come, whatever the metrics come, you will be able to simply visualize it from here. So basically you can do all these things simply just by clicking, dragging and dropping this, because this pipeline is already completed. So once you have done till this part, what you need to do now, if you want to deploy this model, you are completely satisfied with your model performance. If you're not, you can retrain the pipeline, you can change the model. It is very simple. You can just drag and drop it and basically retrain a new pipeline, right? So if you want to deploy it, you first need to create an inference pipeline. So how you can do that? As soon as this whole process is run, you can, as you can see here in the above, there is already basically a section that is available that you can simply using one click, you will be able to create a real-time inference or a batch inference. Like if you want to predict multiple, then you are going to go for batch. If you want just a single input, then single prediction, then you'll go for real-time inference. So you can just simply create it. As soon as you click this, what is going to happen is it is going to create an inference pipeline. Let me show you the inference pipeline that it has created. Go back. So it is going to create an inference pipeline. So this pipeline, I have not created this. So as soon using your existing model, your existing data, it is going to automatically create this whole pipeline workflow for it. So you really don't have to do anything. What you have to, main thing if you want to do, so suppose in this whole inference pipeline, you don't want the data set to be there, so you can completely remove this. And then if you want to do manual predictions, you can, what you can do is you can add sections such as enter data manually, and then you can, because your model is already trained, right? So if you want to enter data manually in basically a CSV format, you can drag and drop it, and then you will be able to get some predictions out of it, right? Through that.
Ayush, I'm sorry to interrupt in between, Ayush, but
sure.
It's already 4:15.
Yeah.
So it would be great if we can wrap up the session soon.
Just 2 minutes. Sure. Just 2 minutes. So basically, once you have created this inference pipeline, you can just run it. So as you can see in the pipeline section, here I have already run this inference pipeline. And that is one of the main part that we are going to be creating. So as you can see how simple it is to just simply create the inference pipeline. And as soon as the inference pipeline is created for deployment, as I told you earlier, like it is very simple. So just like the inference pipeline section, you are going to be having a deploy section, and then as soon as you click the deploy, you will be able to deploy either a real-time endpoint, or if you want to replace an existing endpoint that you have already deployed. So you can give it a name, ML endpoint, suppose, and then you can select, like, depending upon the scale of you want to use. Suppose if you want to use the Azure Kubernetes cluster, you can go for that AKS compute. Or if I'm going to be using simple Azure container instance, as my model is just for training purposes and like simple testing. And if I'm just looking around things, so you will be able to simply choose that compute type. And then if you want to enable the CPU reserve capacity, and then you can also select that, and you can enable the SSL encryptions, and then simply you just have to click deploy. The deployment takes usually like around 20 minutes. So that is it. So after you have created this, because I have not deployed it currently, because it basically costs us money to basically keep the deployment running. I'll show you what it will looks like. So as you can see here, inside, once you go inside the endpoint section, so here you will have a real-time endpoint, or whatever endpoint that you have created. It will be available, and from which you will be able to either test it directly through the Azure interface, or you will be able to get the REST endpoint from the details, and then you can hit it through Postman or other services. So this is how simple it is to basically deploy and create your Azure ML pipeline. So, and I guess that kind of concludes our session. And any questions? Anybody?
Guys, do we have any questions? I think it's a no, Ayush. So
Okay.
we are good to close the session, right? So thank you so very much, Ayush, for the wonderful session. I'm sure it was very enriching for all of us. Thank you.